We're going to go over 9.4, the assignment here, work through some of the questions so you can understand how to do them. So 1 to 5 is grouped together. It says what percentage of any set of data must always fall within and 1, 2, 3, 4 standard deviations. How many full standard deviations are necessary to guarantee 97%? So let's go ahead and look at this. This says any set of data. It doesn't mean mound shape. So when it's any set of data, we use Chebyshev's theorem. And so that's 1 minus 1 over k squared, where k is the number of standard deviations. And so we're just going to plug these things in here. So for number 1, we want 1 standard deviation away. So we'll go 1 over 1 squared. And so 1 minus 1 is 0. And so 0% has to fall within 1 standard deviation. All right, then we'll plug in 2. So for number 2, it says 2 standard deviations. So we're going to do 2 squared. And that is 1 minus 1/4, which is 3/4. 3 divided by 4 is 0.75. And so 75% has to lie within 2 standard deviations. Number 3 is similar. We put a 3 in here, 3 squared. So 1 minus 1 over 9 is 8/9. If you divide 8 divided by 9 is 0.8 continuing. And so that's 88.8 continuing percent. And then 1 minus, I got it for 4 standard deviations. So we're going to do 4 squared. So 1 minus 1/16 is 15/16. And I'm just going to do 15 divided by 16, 93.75. So 0.9375, and so 93.75%. Number 5 is a little different. How many full standard deviations are necessary to guarantee 97% of the data is included? Well, this is the same idea, except we want it to be, we want the percentage to be necessary to guarantee that 97%. So we want it to be greater than or equal to 97%. So we want 1 minus 1 over k squared to be greater than or equal to 97%, which is really 0.97. And so we can do 1 minus 1 over k squared equals 0.97. And now we're just solving an algebra problem. We'll subtract 1 from both sides. And we get negative 1 over k squared equals negative 0.03. We can think of this over 1 and just cross multiply. So we have 0.03 k squared equals 1, because a negative times a negative is positive. Divide by 0.03. So I'm going to slide this over, bring out our calculator. We will divide by 0.03. 1 divided by 3/100ths. And so we have k squared equals 33.3 continuing. Take the square root of that to solve for k. And we get k equals 5.77. So how many full standard deviations are necessary to guarantee 97% of the data is included? So this, you got to be careful of how you answer this. Full standard deviations, here's your mean. Let's say this is the mean. This is saying 5.77 standard deviations away within that much. So it says full, so we don't want to use decimals. So this needs to go out to 6. This needs to go out to -6. So how many full standard deviations are there from -6 to 6? And there are 12 full standard deviations. So if it's, we need 12 full standard deviations to guarantee that 97% of the data is included. Another way to say it is it would have to be within 6 standard deviations, because we can go 6 this way will guarantee 97% and 6 this way. All right, moving on to the next group of 5 questions. I wrote in here already, if a set of data is mound-shaped, okay, mound-shaped means we can use the empirical rule with the mean is 110 and the standard deviation is 3. Number 6, what percent of the data must lie in the interval 104 to 116? All right, so I did a lot of typing for these questions. Let's see how much we can fit in here. So since the mean is 110, the interval is given from 104 to 116. We can think of, okay, that's our mean minus 6 gives us 104, and our mean plus 6 gives us 116. The standard deviation is 3, so we can realize this, the standard deviation is 3, and 3 times 2 is 6, so we had to think through that 2, and so we know if the standard deviation is 3, we need 2 standard deviations in order to or that interval is 2 standard deviations from the mean, but it asks what percentage of the data. So we want to look at our mound-shaped data here. Within 2 is 95%. So our answer is this interval contains 95% of the data. Okay, give the interval containing 68% of the data. Well, 68, that seems like a strange number, but here it is, 68. That's within 1 standard deviation. And so we're going to take our 110 and go 1 standard deviation to the left and 1 standard deviation to the right. So I'm talking through this idea here. From the directions, we know that mean is 110, and so we want to go 3 to the left and 3 to the right. So 110 minus 3 gets us to 107, and 110 plus 3 is 113. So that interval will contain 68% of the data, at least 68% of the data. Number 8, how many full standard deviations are necessary to guarantee 97% of the data is included? All right, so since we want full standard deviations, we talked about this back in number 5, we have to look at whole numbers. In order to guarantee 97% of the data would need to be within 3 standard deviations. So this says 95. There's 95% within 2 standard deviations, 99.7 within 3 standard deviations. So we need full standard deviations, so we're going to jump up to 3. So the answer, in order to get 97, and we're just using full ones, they would fit between -3 and 3. That is a total of 6. So from -3 to 3 is 6 full standard deviations. Number 9, give the interval containing at least 97% of the data. So that's using our answer we just had in number 8. We need to go 3 standard deviations to the left and right of the mean, which is 110. So up here where I'm highlighting, that is each standard deviation is 3, and we want to go 3 standard deviations, so 3 times 3 to the left. So 110, our mean, 110 minus 9, and 110 our mean plus 9. And so that's an interval from 101 to 119. Number 10 says if the data were not mound-shaped. So now we're back to Chebyshev. How spread out could 97% of the data be? Spread out means what's the standard deviation going to be? We need the standard deviation, or the amount of, So the standard deviation is 3 from the directions. So looking at the answer here for number 10, since the data isn't mound-shaped, we need to use Chebyshev's theorem. In number 5, we found that 5.77 standard deviations are necessary for 97%. So add 17.32, which is our standard deviation from the directions, times the 5.77. So we're going to add and subtract that from the mean. So 110 minus 17.32 and 110 plus 17.32. Looks like I messed something up here. So this should be 110 plus 17.32. Gives us that interval right there. All right, the next set of questions use the data below. So there are 15 data points there. Number 11, is the data mound shaped? So I'm going to come down, I'll try to get everything in here. Is the data mound shaped? Well, here I did a distribution table. So I know I have this big old table here, but so that gives me the order. I wrote them in order, so I had 110, 4 11s, 112, 4 15s, no, 5 15s, 2 16s, and 18 and 20. So this definitely isn't mound shaped. So the answer for 11 is no. So we cannot use the empirical rule. Find the interval 2 standard deviations about the mean. So for 12 to 15, we're going to have to go through and find all of our data, all of our different things that we have to do here. So for this 12 to 15, here's where I set everything up. I put my values that's circled there already. So I added them all up and divided by 15. So that's my mean. Added all of my values up, divided by how many are there? 15. And then I did, okay, what's 10 minus 14? The mean was 14. 10 minus 14 is -4. 11 minus 14 is -3. So here's all my subtractions. And then I square all of those numbers. And then we add all of them up. This is our sum of squares. So we learned that variance is sum of squared divided by 15 minus 1, the number of values minus 1, which is 8.14. And then the standard deviation, we take the square root of that. So our standard deviation is 2.85. That took a lot more work than me just talking through it there, but we've done a few of those before. So for number 12, find the interval 2 standard deviations about the mean. So take your mean of 14 and subtract 2 standard deviations, and then take 14 and add 2 standard deviations, which gives us the interval from 8.3 to 19.7. Number 13 is very much like number 12, except now we're doing 3 standard deviations. I'm not going to do that one. Number 14, what percentage of the data lies within 2 standard deviations of the mean? All right. Using our answer from 12, here's our interval. So from 8.3 to 19.7. Well, looking at our values, use the highlighter here, we want to find the ones that fall between 8.3 and 19.7. Well, this is all of these except 20 fall between 8.3 and 19.7. So that's 14 out of 15. So 14 out of 15, we want to find what percentage, so we divide. That's 0.93 continuing, which is 93.3%. Number 15 is going to be very much like that because it asks the same question but has to do with 3 standard deviations. So 13 and 15 go together. And then for 16 through 20, verify the empirical rule. So first of all, the empirical rule, it has to be mound-shaped, so show that it's mound-shaped. So what I did here is I put a little distribution table and we see it's mound-shaped. So it comes up and then down, and I know this 42 looks like it throws it off, but that's okay. It's mound-shaped for the most part, so we can use the empirical rule. And now 17 through 19, you want to verify the empirical rule for 1 standard deviation, 2 standard deviations, and 3 standard deviations. Well, in order to do that, you're going to need to do something like this because we need to find the standard deviation. So you're going to need to put these in order, find the mean, find all the deviations, so subtract the mean from the value. And so it's going to take some work. And then once you get there, you're going to find the intervals, kind of like we did in number 12. So you're going to find these intervals, and then you're going to find the percentage. Once you find the percentage, you're going to look and see, okay, for number 17, yes, it will be within 68%. 68% of them will be between -1 and 1. For number 18, you'll verify, and for 19, you'll verify. So I didn't do the work there, but again, it's going to very much look like the start of that and working through those ideas.